All right, in this video we are going to look at simplifying rational expressions. That's what we want to be able to do by the end, is be able to simplify a rational expression. Just in starting, remember that an expression is just like some x's or some numbers together, like that. 2x plus 7. It's an example of an expression. Or x squared plus 5x plus 6. Those are expressions. So I want to simplify these kind of things. These look pretty simple, but we'll look at some questions where I need to simplify. Keep in mind that it's not an equation, right? And there's things that you can do with an equation that you can't do with an expression. And maybe vice versa. I don't know about vice versa, but they're separate things. So a rational expression by definition is just the quotient of two polynomials. So if I took those two polynomials that I did on that last page, 2x plus 7 is 1, divided by x squared plus 5x plus 6, there's an example of a polynomial or a rational expression. Now, when you look at a rational expression, one of the problems that we get into is that we have an x on the bottom here. And if I have a variable that's on the bottom of a fraction, there's some complications that happen. And really the only complication is that I cannot have a 0 on the bottom of any fraction. So when we're defining the domain of an expression, in other words, what are all the allowable x's for that expression, I have to include numbers that don't work on the bottom. For example, if I had 9 over x, there's an algebraic or a rational expression. If I have an x on the bottom there, there's a number that x cannot be, in this case here. So x here cannot be equal to 0, because you can't have a 0 in the denominator. So if I wanted to say what's the domain of this expression here, I'd say all the x's, or I'll do it the fancy way, all the x's as long as x is not equal to 0. That would be the domain for this. Now, what if you have a different thing on the bottom there? What if you have x, say, minus 2? So the domain of this expression are all the x's as long as x isn't what? And here, I could put a 0 in there, because 0 take away 2, that would be negative 2. But what could I not put in there? Because I'm going to get a 0 on the bottom. Hopefully you've come up with 2. So in this case here, I would say the domain are all the x's as long as x is not equal to a positive 2. That would be my domain. Okay, here's a couple more you can try. This one, there's no x's at all in there. And so in terms of looking at a domain, any x, there's no x's, but there's no restrictions on them. Whereas over here, and if I'm looking for the domain, I don't really care what's up top here. Maybe there's stuff I could do with that, but I'm really concerned about what's on the bottom. And I'm trying to find a number that I plugged in for x there that gives me a 0 on the bottom. Since this is quadratic, it might make sense to factor that. 7 and 5, I think. So x plus 7 and x plus 5. And then whatever was up top there. So the domain, I can use any x's I want here as long as it's not equal to a negative 7 and it's not equal to a negative 5. Plug in any x you want there, just don't plug in a negative 7 and negative 5. Because if you do, you get a 0 on the bottom of a fraction, and that's undefined. Okay, so when we're simplifying an expression, what we're looking for is something that's the same on the top and the bottom, or similar factors that are in the numerator and the denominator. If I have those, then I can remove them. For example, if I have 2 over 4, you probably look at that and you're automatically thinking 1/2. Well, I can simplify it doing this. 2 is the same thing as 2 times 1, and 4 is the same thing as 2 times 2. So here I've got a factor of 1, because 2 divided by 2 is equal to 1, right? So it's really, this is 1 times 1/2, and anything multiplied by 1 is just equal to whatever this is, or 1/2. That's the kind of thing that we're wanting to do. So we often will factor the top and the bottom and look for an identical factor that I can remove as a factor of 1. Let's try a couple questions where we have that. So t squared minus 16, I'm going to factor the top. That's a difference of squares. I'll factor the bottom. That's t minus 4, I think, and t minus 4. If you factor that. So here I see the identical factor on top and bottom. Typically, what we've done in the past is you just cancel those. That's what you call it. And I guess you can do that. But really, t minus 4 over t minus 4 is the same thing as 1. So I'm removing a factor of 1. So my answer will wind up to be t plus 4 over t minus 4. Here's a couple. Maybe try these two. You can't really see that second one. Let me move it up a bit. Try these two and just see how you do. They're both multiplying. And basically what you do, I'll do the first one. You factor, oh, this is equal to. So I factor that, that'd be x minus 4x plus 4. Factor this one, I could take an x out. On the bottom there, I've got x squared. I'll write that as x times x. I could have left it, but. And then this one, let's factor that. There's a times here. It'll be x minus 4, x plus 3, I believe. Yeah. Now I look for common factors on the top and the bottom. There's an x here and an x there. So it's a factor of 1, I can remove it. And x minus 4 there and an x minus 4 there. Common factor 1, I can remove it. Now, looking at what I have left, I don't think I have anything identical on the top and bottom that I can cancel. I can't take this x with this x because this x is not the whole factor. So I can't cancel those. So I'm going to be left with on the top x plus 4 times x minus 4, and on the bottom I'll be left with an x. Same kind of thing with this one on the bottom. I'll just do it quick for you. It'd be y minus 10, y plus 1. And this will be y minus 1, y plus 1. That's this. And then up here I have a y plus 4. And then on the bottom, is this right? I don't think that's right. This should be a 9. Y squared plus, oh, and this one has to be a minus. Boy. Okay, good. I think I got that right eventually. And then here this will be a y minus 9 and a y plus 4, I think. Is that right? Yeah. Okay, now look for factors of 1 that I can eliminate. There's a y minus 9. There's a y minus 1. There's a y plus 4. Ooh, I like canceling. So on the top, there isn't anything there, so I can leave a 1. And on the bottom, I'm just left with a y plus 1. So that would be the answer to that one. And there's lots of things you can do. Like this one is dividing, but I do the same thing, factor everything. But this second one I have to flip over, right? And then eliminate factors of 1. Now, if I'm adding or subtracting rational expressions, if it's a fraction, I have to have a common denominator. So in this case here, I've got a common denominator, so I can write the whole top thing. So I have 4x plus 5 minus x minus 2 all over the same denominator. Now notice that I wrote this one with 2 brackets there. Because they're fractions, it's like there's brackets there. But that's a key thing for this one because that there is a dirty, rotten, filthy, stinking negative. So if I drop brackets here, it'd be 4x plus, well, that was a 5. Oops. 4x plus 5. And then here this would be a minus x plus 2. Lots of students get that one wrong right there. All over x plus 3. Collecting like terms on the top, I'd come up with 3x plus 7 all over x plus 3. Okay, so that's that negative sign. That is one to keep track of. Here's another one, 2 rational expressions, but this time they don't have common denominators. Easiest way to get a common denominator is factoring that bottom thing. So I could factor that to x minus y, x plus y. Oops, that's an x. Plus y. Plus on here I've got 2 minus 3x all over x minus y. Now this one has an x minus y, so does this one. But this has an x plus y, this one doesn't. So to get a common denominator, I've got to give this one an x plus y. But if I do that to the bottom, I also have to do that to the top. Now I've got a common denominator, so I can write my x minus y, x plus y on the bottom, and then I collect like terms and do the stuff on the top. So the top I'd have 3x squared plus 3xy. And then here, I could FOIL all that out. So it'd be plus 2x plus 2y minus 3x squared, that's that one, and a minus 3xy. Now taking a look at to simplify this, a 3x squared minus 3x squared, those cancel, so they're gone. 3xy minus 3xy, they're the same. They're one's plus, one's minus, they cancel. So on the top here, all I have is a 2x plus 2y over x minus y, x plus y. At this point, I'm feeling real good, but at the top there, I could factor that. I could factor a 2 out. That would leave me with x plus y. And on the bottom, I have x minus y, x plus y. And lo and behold, here's a factor on the top and the bottom that are the same. I can eliminate those. So my answer to the simplification of that top question is just 2 over x minus y. Notice that there's lots of ways I could have done that question. I could have maybe factored this top thing, factored that, see if I could cancel anything. So there'd be other ways that I could have done that question. But all of them will come out to that. Here's just another question where you could do that. Let me just show you that one quickly. So I have 5y over 1 minus 2y, minus 2y over 2y plus 1, plus, this is the one I wanted to get to, so I want to factor that. So it'll be 2y plus 1 and 2y minus 1. It's a difference of squares. Now, I'm feeling pretty good here because it's the same, but this one, it's not the same as that. One way I could do that is I could multiply both top and bottom by a negative 1. And what happens when you do that is it changes the sign on the top and it changes the order on the bottom. That's just a nice little trick that you may have learned in Math 85. Okay, I'm just going to write everything else down. 3 over 2 plus 1, 2y minus 1. Okay. Now, to get a common denominator, this one has this one and that one. So I'm going to need to take each of those terms, this one, and to get a common denominator, it also needs a 2y plus 1. Do it on the bottom, have to do it on the top. This one doesn't have a 2y minus 1, so I need to multiply that by 2y minus 1, and same thing on the bottom. Multiply it by 2y minus 1. So, altogether, on the top here, I have 2y plus 1 times negative 5y minus 2y times 2y minus 1 plus 3. This one already has both those factors in the denominator, so I don't need to include anything up top. And all of this is over my lowest common denominator of 2y plus 1 times 2y minus 1. Now simplifying, let's FOIL things or use the distributive law there. So that would be negative 10y squared minus 5y. Here this would be a negative 4y squared plus 2y and plus 3 all over my lowest common denominator. Still simplifying, 10y squared minus 4y squared, negative 14y squared. Minus 5y plus 2y is a minus 3y and a plus 3 all over my common denominator. And I think maybe you can factor that, but I don't think so. So I think that at this point I am done. Okay, so that is manipulating, simplifying, doing things with rational expressions. Fractions, everybody's or not everybody, but many people struggle with those. They're ones to practice. And if you do enough questions like these ones up here, or this one, they start looking the same, and that's what you want to do.